Hello and welcome to this video about geometry vocab needed for 6th grade geometry. So this video comes with a warning. Warning, get ready to draw while you're taking your notes. So in addition to maybe writing some stuff down, we really need to draw some pictures that go with this. So that being said, let's get into our first category, measurement. Now, measurement refers to crunching some numbers. Kind of like when you're measuring something, you look at some numbers and you quantify it with, it is such and such long. But what we're going to do now is we're going to focus on two main measurements at the very beginning. We're going to focus on area and perimeter. Now, these are some ideas that hopefully are familiar to you, but just to make sure that we understand them. Area is the space an object takes, and a perimeter is the distance around it. Okay, so we have area as the space, and then perimeter is the distance around it. So for area, this will be our little image here. Draw a rectangle, and then inside it we have all that coloring going on. That is the space. Whereas for perimeter, what we're going to do is, again, we'll draw a rectangle. Let me scroll up a little bit there. And then our perimeter is going to be the distance around it. So perimeter is that. If you had to, have a piece of string to go around the perimeter, or to go around a shape, that is its perimeter right there. So later we'll get into actually, solving some problems, calculating area, perimeter, and then doing problem solving with area and perimeter. Next though, let's talk about shapes. So a couple of basic things I want to kind of address right off the bat. First of all, what it means if something is a regular shape. So a regular shape is one where all sides and angles are the same. And so to the epitome, the classic example of this would be your square, where each side is the same. Now in geometry speak, the way or kind of notation I should say, we put a line through something, and anything that has this line through it is considered to be the same as any other thing with that line through it. So all those sides are the same. And then with a square, you have a right angle, and to show a right angle or an angle that is 90 degrees, we put that little we try to make it look like a square down there. And again, that means that this is 90 degrees. And if that shape is there, that means they all have 90-degree angles. But if we were to look at something like a triangle, and we'll define this a little bit later, but what kind of triangle this is, it has the same length. It also has the same angles. Now, those aren't right angles, so we're going to use like a little circle to show that those are all the same. And again, what this means and this means is that these are the same angle. And again, we'll see that a little bit later. And now, regular shapes go for any size or any number of sides you have there. So we could have regular pentagons, regular hexagons, octagons, so on and so on. But now let's talk about, a little bit more about shapes. Two categories that we're really going to focus on are triangles and, here's a fancy word here, quadrilaterals. All right, now triangles, tri means three, angles is an angle, so we're looking at something with three angles or three sides. You already know that. Quadrilaterals, you can probably guess. Quad meaning four, laterals meaning sides. We're looking at four-sided figures. And when it comes to describing these four-sided figures, we have different ways of quantifying them and describing them. And so let's get to that now. So when it comes to triangles, we have a line in the sand where on one side we like to talk about them in terms of their sides, and on the other side we like to talk about them in terms of their angles. So some vocab that goes with sides would be something like an equilateral, there you go, triangle, or an isosceles triangle, or a scalene triangle. And we'll draw all these in a second here. But essentially what this means is that we have 3 equal sides, we have 2 equal sides, and here we have 0 equal sides. All right, so that's one way of kind of looking at some triangles. The other side is by their angles. And so we have right triangles, we have obtuse triangles, and then finally the very popular acute triangles. All right, so let's talk about what all of this means. So first, let's address equilateral. Well, equilateral is simply just the regular triangle like this, where all 3 side lengths are congruent. They're all the same. Isosceles is where we have 2 of them. Now, an isosceles triangle could look 2 different ways. It could look like this, very classic rendition of it, where the 2 side lengths are longer than the other one. The 2 congruent ones are longer than the other one. And also with isosceles triangles, the 2 bottom angles like this are the same. But another way we could draw an isosceles triangle is where the equal sides are shorter than the other side. So it could look like this, but again, these 2 angles are the same. So if you have 2 equal sides, it's considered an isosceles triangle. Finally, the scalene triangle could look something like that right. Well, let me make it a little bit better than that. Where you have 3 sides, none of which are equal to one another. Maybe something like that right there. So you have 3 different side lengths, 3 different angles. All right, now let's talk about the these triangles classified by their angles. So right angle, again, that means 90 degrees, and that means that you're going to see that symbol right there. So a right triangle would look something like this. And it has to have that or something that says it's 90 degrees. Again, there's many ways you can draw. It could be very tall and skinny like that. Sometimes you can put the right angle up here. And in fact, when you do that, this becomes an isosceles triangle. But again, we want to know if it has that 90-degree thing. Obtuse means that we have an angle that is greater than 90 degrees in our triangle. So for an obtuse, it could look something like this right here, where this angle is clearly larger than 90 degrees. And then acute means that all the angles are less than 90 degrees. So acute could look like that right there, where each one of those is clearly less than 90 degrees. And again, some of these overlap. So I mean, just because it's acute doesn't mean it can't be an equilateral or isosceles. So in an equilateral triangle, they're all 60 degrees. We'll talk about that later. It's also acute. Isosceles, same thing. As long as all the angles are acute or smaller than 90, the whole triangle is an acute triangle. So there is some terminology we have for triangles. Finally, let's talk about quadrilaterals. When it comes to quadrilaterals, we usually care about, there's many ways you can describe it, but the ones we're going to focus on here in 6th grade are centered around the question, how many parallel lines do we have? All right, so first of all, you're familiar probably with the basics, so you have your square and you have your rectangle. And so a square, you have 4 equal sides and 4 right angles like that. A rectangle, you have 4 right angles, but the sides may not necessarily be equal. So as all squares are rectangles, but not all rectangles are squares. So these sides are going to be the same. These sides could be different, and that's cool. Now notice that with both of these, we have 2 sets of parallel lines. And it's not the only way we could draw a quadrilateral with 2 parallel lines. So we have another quadrilateral, which is a parallelogram. And that means that we have 2 sets of parallel lines. Again, these can be drawn in several different ways. Classic way to kind of draw them would be something like this, where green lines are parallel to each other and the yellow lines are parallel to each other. And the big thing is that they are all Yeah, we have two sets of parallel lines. Again, we could redraw it a different way. Sometimes you could draw it like that right there. It could be rotated, but just as long as the lines are parallel, then you call it a parallelogram. The other shape that we're going to talk about is where we have one set of parallel lines, and that would be a trapezoid. So one set of parallel lines. Classic drawing of a trapezoid is something like this. Now this is cute because like it kind of this matches that, if you will, but these, the top and the bottom line, are the parallel lines. But this is also a trapezoid. Because again, here we have a parallel line, here we have we have one set of parallel lines like this. We could rotate it and draw it like that right there. That's also a trapezoid. We could have one where it's just straight up upside down, and maybe the lines don't really match each other all that well, so like that one's not quite as, there we go, let's make that one a little even longer like that. We still have a parallel line here, parallel line, or these two lines are parallel, but these lines don't even come close to mirroring each other. But that's fine. As long as you have one set of parallel lines, you have a trapezoid. So this is a nice little sort of summary of all the words that we're going to be using over the next couple of weeks. Hopefully you drew in some of those pictures, so that way when we get into the ideas behind them, you're familiar with the vocab and you're able to put it all together.